In this video, we're going to use the product, the quotient, and the power properties of logarithms to solve for x in each of the three problems below. For our first problem, we have log base 4 9 minus log base 4 11 is equal to log base 4 x. Now keep in mind, to use these properties, we're going to have all the same base on our logs, but we do in each of these problems, so that's just something to look out for in the real world. So now what we can do for this one is, since we have two logs that are being separated by a subtraction, we can turn that into one log where we divide what is inside of the original logs. And so in other words, log base 4 9 minus log base 4 11 becomes log base 4 parentheses 9 divided by 11. And again, that's because there was subtraction. Subtraction between two logs is the same thing as division between the two things inside of the two logs. And so now the left-hand side of this equation has gone from two terms to one term, and we can not do anything with the right-hand side. We're just going to say it's equal to log base 4x. And so now we have log base 4 of something, 9 over 11, is equal to log base 4 of something, x. And so since we have log base 4, and we have equal sign in between the two, then obviously these terms have to be equal. And if you're doing the same thing to both sides of the equation, then everything remains constant. And so log base 4 of something has to equal log base 4 of something. The two somethings, even though they may not look like it, have to indeed be equal. And so therefore our answer is just what's left over. X is equal to 9 over 11. And so the reason we could do this is because we were able to reduce it down to just a log on one side base 4 is equal to a log on the other side base 4. And then you could set the insides equal to one another. So now the second problem, notice we don't have subtraction between the two logs, we have addition. And so this time we're going to use the product property. And so just like subtraction between two logs, it goes to being dividing the things inside of the logs. The addition between two logs is going to turn into multiplication between the things inside of the two logs. And so again, we can condense the two logs, log base 3 2 plus log base 3x, into just one log base 3 parentheses 2 times x. So we just condensed the two terms on the left-hand side of the equal sign into one term, and we're going to set that equal to just the right-hand side, not making any changes there, log base 3, 14. And again, now we have log base 3 of something is equal to log base 3 of something, so the log base 3's can cancel out, and that gives us 2x is equal to 14. And to solve for x, we can just divide both sides by 2, so we get x is equal to 14 over 2, or 7. So now we've looked at the quotient and the product properties of logs. The last problem is going to use our power property of logs. And so notice we already have log base 8 16 is equal to x log base 8 2. Now here's where you have to be careful. We don't have log base 8 of something is equal to log base 8 of something. We have log base 8 of something is equal to x times log base 8 of something. So what we have to do is we have to find some way of dealing with this x before we can just cross off the logs. And the way we're going to do that is use the power property. And so this time nothing changes on the left-hand side. We have log base 8 16, but that's going to be equal to log base 8 of 2 to the x power. Because whenever you have a coefficient out in front of a log, you can bring it to be the power of what is inside of the log. And so now we can do our little trick. We have log base 8 of something is equal to log base 8 of something, so the log base 8's cancel out, and that's going to leave us with 16 is equal to 2 to the x. And all this is asking is 2 to what power is equal to 16. So if you know that answer is 4, you're good to go. If you don't see that quite yet, just change the 16 into a power of 2 so that you get the 2 or the same base, and you'll have 2 to the 4 is equal to 2 to the x. And then just like we were able to cancel out the logs, we have the same base on both sides of the equation, and so now you can cancel out the 2's. And so what that leaves is 4 is equal to x. And so that's it. That's just a good little short way of showcasing the quotient and the product and the power properties of logarithms. And in general, anytime you have logs and you want to condense them in these ways, you can do that.